Welcome to the Explainer. Let's dive into the absolutely wild physics and mechanical ingenuity of helicopter flight.
These machines are inherently unstable. So how do they stay up without just spinning out of control?
It starts with relative wind. Think of sticking your hand out a moving car window to feel the air.
The rotor blades act as airfoils. They slice through that wind, generating upward aerodynamic lift to conquer gravity. Unlike symmetrical shapes, cambered or curved airfoils produce massive lift, even with some really tricky pressure shifts.
Once we've actually created lift, the pilot has to direct that immense force using highly sensitive mechanical controls.
It boils down to three controls: the cyclic steers, the collective alters lift, and pedals point the nose.
Pulling the collective lever equally pitches all blades at once, so the aircraft goes straight up or down.
Pushing the cyclic tilts the whole rotor disc, literally dragging the helicopter straight ahead into forward flight.
But here's a huge problem. Newton's third law means spinning the main rotor forces the fuselage to spin backward. That's why the tail rotor pushes horizontally against the torque, stabilizing it and allowing for precise pedal-controlled steering. The catch? Traditional tail rotors drain 10% of engine power and pose extreme hazards to ground crews. So engineers invented brilliant alternatives like enclosed fenestron fans, air-ducted no-tar systems, and counter-rotating tandem main rotors. Juggling all these physical forces simultaneously makes hovering the absolute most difficult aspect of flying a helicopter. Hovering essentially blasts a massive column of air straight down, creating a super powerful induced flow called downwash. Close to the ground, the surface interrupts this downwash, massively increasing efficiency and drastically reducing required engine power. The kicker is that hovering low also minimizes those turbulent rotor tip vortices, generating maximum lift. With tilt rotors and tip jets redefining vertical flight, how do you think we'll conquer aerodynamic instability next?